Yeah, nothing cancels it out, so it's part of the leftover bit. And this was a sum of two terms, and now it is a product of two factors. Now, this factor is linear. Is this factor linear? No. It's what's called a quartic, a fourth degree. Okay? So I'd have to ask myself, wait, I still have an exponent, but that's not, as we move forward, you'll see that's not something. It's a binomial, so maybe it's a difference of squares. Well, y to the fourth is a perfect square, but 7's not. So you're done. Okay, so that is prime. Now the whole thing isn't prime because you were able to take out a GCF. So don't write prime now, you're just finished. If you could do nothing at all, you write prime. Okay? But if you can do something, anything, it's not prime, but you know you're done when each factor itself is prime. Okay? And you can always then check, remember, by undistributing. So I would check my work by, or we just undistributed, where I check my work by distributing. So 3x times 1 minus 3 times 7, x times y to the fourth. Unlike terms, this is not the product rule of exponents. I just have to put x next to y to the fourth. And check, check. I'm good. Back to where you started. Okay? Given the time, you can always check your work with factoring by remultiplying. Okay. All right. So negative 9x plus 3x squared minus 6x cubed. Now let's make a note first. What is the GCF? Look numerically first. 3. And how many x's? Just 1. Yeah, because there's 1 here, 2 x's here, 3 here. The most they have in common is 1. Okay. Now there's actually another GCF. There's always 2 GCFs. What would the other one? And how can there be 2? Because GCF stands for greatest common factor, and greatest implies there can only be one greatest. No, that wouldn't be a GCF then, because we'd still have some stuff left over we could have taken out.
Would it be negative 3?
Right, negative 3x. Right. There's always a negative version. You can pull out either the positive or the negative version. In general, pull out the positive version. But you might want to pull out the negative version for a couple of reasons. One, because you're told to. Or two, another reason to instinctively do it is if your leading term is negative. Because if you pull out a negative GCF, it will make your leading term positive, which is usually preferred just because it looks better. Okay? Both of these are mathematically correct. But as we move into the 4-term polynomial grouping, this is going to be very important. Working with a negative GCF is going to be key to making the next factoring technique work. Okay? All right, so let's, in this case, you could do either one, but let's, in this case, because there's a leading negative, let's take out the negative version. Okay? So 3 terms, have to be fair to every term, and we'll pull out the negative version. Now the example is on the PowerPoint, just pulled out a negative 1. If you have nothing else in common, but you want to flip the signs, you can pull out a negative 1. Or if the leading term is negative, just pull out a negative 1. Dividing by negative 1 does what to each term? Positive. Yeah. It makes it positive. Well, if it's negative, it makes it positive. If it's positive, it makes it negative. So it flips the sign. Yeah. It doesn't change anything else about it. It just flips the sign. Okay. So even if you just have you can pull out a negative 1 just to flip every sign if you need to for some reason. Okay. So I immediately write down my negative 3x is my GCF, and immediately that's one factor. Is it linear?
Yes.
Even if it had an exponent, because sometimes you can pull out an exponent, you're still done. If it's just a monomial, if it's just one term, there's nothing else you can do. You could really expand it and write it out. Like if it's x squared, you could write x times x, but that doesn't really, you don't need to do that. Okay, so if it's a monomial, you're done. But it's part of the answer. That's factor 1, and now a parenthesis. And factor 2 is going to have how many terms inside of it? 3. Yeah, it started off as trinomial. What's going to be left behind is a trinomial, but divided down. Now this is, again, where I pay attention to the signs. Is my first term going to be positive or negative?
Positive.
Right. So it's positive 3, and then the x's. Now, like I said, this is my strategy. I see I've got a positive 3 and a negative 3. What is my sign going to be?
Negative.
Right, so I just write subtraction. Got mixed signs. I just write subtraction, and now I don't worry about it. I just do 3 divided by 3, obviously. And x2 x squared divided by x.
X.
Would just be
Yeah. Quotient rule, 2 minus 1. Visually, you're thinking, 2 on top, 1 cancels out on the bottom. But by the quotient rule, 2 minus 1 leaves x to the 1, or just x. Okay. Now, I've got minus 6x squared. I'm being divided by negative 3x. Am I going to have a plus or a minus here? A plus. Good. I take care of that, and then I just do 6 divided by 3. X cubed divided by x. X squared. Right. 3 minus 1. Close my parenthesis. And I can distribute to check. And mathematically, you could have just pulled out if you wanted to, or if mathematically, it might be going against the directions you were given, but mathematically, you could pull out a positive 3x, and you would be left with a negative 3 plus x minus 2x squared. And this would be correct also, unless you were asked specifically to do this. Okay? Both of these are mathematically correct. Okay, so you do these.
I have a question.
Oh, yes.
Okay, so negative 6x, and you put the GCF negative 3x, and you put under plus, right? You dropped it down.
Here? Mm-hmm.
Yeah, but the one next to it, it's a plus and a negative, and you decided to put negative
Because this is like positive 3 divided by negative 3. And a positive divided by a negative is?
Negative.
Right. So if your signs are mixed, then you're going to have subtraction. See, that's my strategy. I just see, is it going to be plus or minus, and then I don't have to worry about, my negative positive rules. I just see if I've got the same sign, both negatives, or the same sign, both positives, I know it's going to be positive or plus.
Well, you can also see like
It's mixed signs, it's subtraction.
in the first one, like a negative times a negative.
Uh-huh.
Like to solve it, to check back,
Uh-huh.
to factor it all out, or to negative 3 times negative x would be positive.
Negative 3 times,
Yeah, like if you were
Like the one at the
distributing.
bottom?
Yeah,
oh, yes, uh-huh.
so that's how I would see it.
Great, yeah, and yes, exactly. There's other strategies, how you organize your brain to see that strategy, yeah. What I'm demonstrating here is mine, because I know my careless mistakes and other general common careless mistakes. It's like, how do you know if it's positive or negative? That's why I try and not think of these as positive negatives. I just think, okay, that's positive, the first one, and after that I'm just thinking, is it a plus or a minus? If it's mixed signs, it's going to be minus. And if it's two negatives and two positives, it's going to be plus. And then I just do my division. But you're seeing it. If you see it a different way, that's great. Yeah.
So whenever you chose the greatest common factor,
Mhm.
it's negative 3x.
Yes.
Was that just to switch the signs? Like you could have done either one?
Either one. Both of these are mathematically correct. Yeah. Instinctually, if you have a leading negative, instinctually I tend to take out a negative GCF, or if the directions say, take out a negative GCF. And like I say, when we do the next factoring type, 4-term grouping, you'll have to do it on one of the steps in some problems.
But you don't necessarily have to go with negative 3x how you started.
No, since I didn't write directions out, both of these, it could have been done either way. That's why you show both of these are mathematically the same. If you distribute this or you distribute that, you're going to end up back here either way.
So how would you write it down if you did want it a certain?
What do you mean?
Like if you did want it, like as in the positive one, like just 3x,
Yeah.
like you said, how would you ask for
If I want that specifically, I would say factor out the positive GCF or factor out the negative GCF. And if I wasn't specific, if I just said factor,
Then
it would be your choice.
either one.
Yeah. And like I said, the next technique I'm going to show, there's a case where you have to do it, and I'm going to show you how you know when you have to do it. It won't be in the directions, but you'll know you have to do it based on what you're looking at. That's why I bring it up here as well, too. Okay. Other questions? Okay. I'm going to put these up here, put 3 up here. So feel free to work together or separately. It's up to you. And let me know if you need questions. So this will bring up just a couple other sort of topics and things you might typically see. all 9.1. And we'll start in on, we'll introduce 9.2 at the end of class. Like I said, if you feel like you need more practice or more explanation, in the textbook, this is 5 point.
6.1.
9 point something.
Yeah, 6, chapter 6, right? It's 6.1. Yeah. So yeah, 6.1 is the 308 material. It's the same type of factoring, so it goes in a little more detail. 9.1 is a little more condensed review. Both those sections will. The homework is from 9.1, but it's the same type of problems you'll see in 6.1.
Someone's at the door.
Oh. So what about this first one? How many terms are in this polynomial? Right. So you got a trinomial. Right. Do they have anything numerically in common?
No.
Just one, right? 1 is actually the GCF, but when you divide away a 1, does it change anything?
Nope.
No. So a GCF of 1 means there's nothing to do. And if any of your terms is a constant 1 or a coefficient of 1, if any is 1, then you're not going to have a numerical GCF. Because remember, your GCF is either the smallest one or smaller, and you're not going to go smaller than 1. Yeah, you could take out a negative 1 if you just want to flip the signs. Okay. Now what about variables?
X2.
Square.
So you take x squared out of here, and here, and here? No. Yeah, x squared is common for these two, but not for that one. If it's not good for all three, so is there anything you can factor out of that one? No. And because there's nothing you could do, we call it prime. Okay. No GCF, aside from 1 or negative 1 if you wanted to flip signs.
So if it was like that, another number that could possibly go into 3 as well, but
Mhm.
there was no common in the variable,
Mhm.
would it still be prime?
No. Let's say this was a 6.
Uh-huh.
Then if this were a 6 instead of a 1, what would your numerical GCF be?
3.
3. And so you would divide a 3 out. So just like I said with the PowerPoint where we left off, you might have a numerical GCF or a variable GCF or a numerical and variable GCF.
So it have to be the two together?
No, it has to be, if there's something they have in common, a number, a variable, or both,
Okay.
or positive or negative, then you got a GCF. They don't have any number in common, but if they did have a 6 here, then 3 would be in common. You divide that out, that's your GCF, a numerical GCF. Yeah. And that would be it. Mhm. If this was a 3x, then you'd have a 3x in common. Yeah. Or if this were an x, you'd have no numerical variable,
Put an X.
but you'd have an x. You'd divide out an x. Mhm. no numerical GCF, but you'd have a variable GCF divided on an x, yeah. Be one or the other or both, and then positive or negative. Now, looking at this by 38 and 57. Now, I got two terms here, right? Okay. So, is there a GCF of 38 and 57? Are these on your multiplication chart? I mean, I hope you know everybody knows they're 12 by 12 multiplication, right? But are these on it? No, I mean, like, I want you to be able to mentally know, oh, those are divisible by 2 or 3 or 4 or 5 or 7, 8 or 9. But just because they're not on the multiplication chart doesn't mean they don't have some common factor. Did anyone find one? Because people do one of two things generally. You either start dividing on the calculator, guess and check, guess and check, guess and check to see if something divides both of them, or you're like, nah, there's not one, and move on. If you did that, you'd be wrong. So, would you like a little calculator assist on this? I mean, that's not on the multiplication chart, so I've got good mental math skills from years of practice, but even I looked at that and went, not sure. Okay? So, smaller ones like, say, 3, I hope you can see mentally that 3 is the biggest thing that'll come out of both of them. If you use the calculator for that, you're using the calculator as a crutch. Okay? But this, here the calculator can be a good tool. So here are the calculator directions for working with this. So you're going to go to your math button, the math menu. Okay. All right. So the math button, when you click math, you've got 4 menus across the top. I think some of the newer, fancier ones have like 5, but you only need 4. So lots and lots of stuff in the math button over here on the left. You need to arrow over to the number menu. So now the number menu is highlighted. You see the first thing should say absolute value. This is how you enter absolute value if you wanted to graph one of those or use absolute value. Okay, now you see this arrow down here says keep going. There's more to the menu. You can arrow down to highlight it, or once you remember what the number is, you can just push the number on the keypad. The number is 9, but let's look down. If you scroll down, you'll see it. I want to point out number 8. LCM, least common multiple, is the same thing as LCD, least common denominator. So what I'm about to do with the greatest common divisor, which is also the greatest common factor, you can also do for LCM. Remember, multiples and factors are different, though. When you're finding an LCD, remember, you always want to choose the biggest denominator or bigger. Okay? So if you enter your 2 denominators here, you can only do 2 at a time. I'll show you why. You can only do 2 at a time. So if you had 2 denominators, you'd enter the denominator 1, comma, the second denominator, and when you push enter, it's going to give you your greatest common denominator. Sorry, your least common denominator, which will either be the biggest number you put in or bigger. Okay? The GCD, factors or divisors, are always the smallest one or smaller. So if you put in your 2 your 2 coefficients and push enter, it's going to give you the greatest common divisor, the biggest number they have in common, which is either going to be the smallest one or smaller. But the buttons work the same. So if you wanted to go back and practice, like when we go over on Tuesday, I give the test back and look, I need to work on those fraction problems. This is a calculator backup to finding that LCD. Okay. I hadn't shown that before because all the LCDs I gave you should be in the mental math realm. But know this now. You can go back and use that as a backup if you're really hurting with the linear equations and finding those denominators to kill the fractions. You can use this until you get more comfortable. Okay, but we're going to number 9. Once you remember it's 9, once you go to number menu, you can just push 9. Okay? Or you can scroll down and find it, GCD. That's going to give you GCD with an opening parenthesis. Now you can only enter 2 at a time. Okay? It's going to give you an error if you enter more than 2, and you can only enter positive. Yeah, this is positive 38, negative 57. Doesn't matter. You just enter the positive version, so you're going to get an error. You decide then whether you're pulling out positive or negative. Okay? So I enter 38, comma, 57, and close the parenthesis. I want the GCD, the GCF of those 2 numbers. Push enter. Oh, there is one. We definitely haven't memorized our 19 by 19 on the multiplication chart, right? So that's not an obvious one. So I know 19 is a factor. It'll divide out of both of them. Now, if I'm not sure what 38 divided by 19 or is it 57, then I can just do the division. But I don't have to guess and check a whole bunch of division to find that out. Now, is there a variable GCF? Yes. What is it? X. They have one X in common and? Yeah, and they have y to the 4th in common. So both of them have x, y to the 4th in common. The smallest exponent will be the most you can take out of any of them, of each like base. Okay, so that's my 19xy to the fourth, and immediately put up my parenthesis. Now 38 divided by 19. And then how many x's do I have left? Right, 2 minus 1, I have 1 left. X to the 1. Okay, so here's what I was referring to before about the 0 exponent. You know y fourth over y fourth. Anything over itself cancels out, right?
Yeah.
Okay, this is why algebraically it's true. By the quotient rule, dividing like bases, subtract the exponents. What's 4 minus 4? 0. This would be y to the 0. What is y to the fourth divided by y to the fourth? Something over itself equals 1. So anything over itself equals 1. By the quotient rule, this would be y to the 0. So y to the 0, or anything raised to the 0 power, equals 1. Because what it means is something over itself. Subtract the exponents. Plus or minus? Minus. And then 57 divided by 19? 3. And the x's and the y's all cancel out. Okay? This is 1 minus 1, or x to the 0, and y to the 0. But anything over itself, you know, it's a factor of 1, so it cancels out. Oh, and this right here, I'm going to show you one other example with the calculator if you have more than one variable. So that was math, and then over to the number menu, and then you scroll down to number 9, which is GCD. Okay. And so when we entered the GCD and we entered 3857 and closed the parenthesis, then the calculator returned the 19. Okay. And that is our GCD. Okay. Now, if you have 3 numbers, you can only enter 2 at a time. So let's say you wanted to find the GCD of 24, 36, and 8. Okay. Now I could write these as coefficients of a polynomial, the same idea. If these were your coefficients, and you want to see if there was, there were 3 terms and these were your numerical part, so you want to find the GCD of these 3 numbers. Well, you have to do 2 at a time. Okay? So you're going to go to Math, Number Menu, and then, sorry?
What's the last number?
Oh, 8. Sorry, yeah. 24, 36, and 8. Okay. So Math, Number Menu, and scroll down or choose number 9. Okay. So we're first going to enter GCD of 24 and 36. Positive, whether they're positive or negative in the polynomial, positive versions. Okay. 24, comma, 36, close the parenthesis, and we get 12. Okay. So the calculator returns 12. Okay. So that was our first ones. Okay. Now we take the result and our third one, and we GCD again. So enter GCD, Math, Number Menu again. All right, there we go. So Math, Number Menu, number 9. And we enter the 12 that we just got from the first 2, comma, our last one, which is 8. 12, comma, 8. And that gives us a GCD of 4. Okay. So this right here is then our GCD, our GCF. Okay. So we had to do 2 rounds. If you have 4, you have to do 3 rounds, 2 at a time. Okay. Do the first 2, take the answer with the next one, and so forth, until you've run through your whole list. Okay. And remember, it's always going to be the smallest one or smaller. 4 was not in this list, so you're always going to, if you're doing it mentally, that's the way to think about it. 8. It's either going to be, the smallest one is 8. Well, is 8 a factor of 24? Does 8 divide into 24?
No.
Yes. 8 times 3. Does it divide into 36?
It doesn't.
No. Yeah. So 8 is not a factor or a divisor of both of these. Okay, so your smallest one didn't work. So with the common denominators, you did the biggest one or bigger. So you went up from the biggest one. Here, the smallest one doesn't work, so now you go smaller. And you think factors. Well, if I count down the factors of 8, then 8 didn't work, so what about 4? Because the factors of 8 are 8, 4, 2, 1. Huh? 4, oh, yes and yes. So mentally, that's how you arrange it, but if you get stuck or you got really big numbers, the calculator's a backup for that. But do understand, smallest or smaller. Okay. All right. Okay. How many terms do I have here in this one?
4. 2.
2. This plus sign right here, this tells us it's a sum. Yeah, there's pluses and minuses elsewhere, but they're locked up. This is like 2x, but my x is a quantity. It's more complicated than that. But it's still like one term, a little pocket, a little thing, a little entity of 2 times a variable, but my variable is messy looking. Okay? But there's no addition or subtraction in here. Not that's not locked up. So this is my one term. And this one too. This is another term. So I have a total of 2 terms. Okay? So that's my polynomial, a sum of 2 terms. So if I'm asked to factor this, I need to look at these 2 terms and see, is there a GCF? Do they have anything in common? I can look at the beginning part before the parentheses, 2 and 3y. That's like looking at the coefficients. Anything in common there? Either a number or a variable? No. So let's look then at their quantities here. Are those in common? Yeah. If they match, you can divide them away. I've got 2 terms, so draw your 2 bars, and anything that they have in common goes underneath, divided away. You're dividing away, keep it in parentheses, you're dividing away that entire binomial. You keep it in parentheses because it's one whole chunk, it goes together. All or nothing. Now, that was my GCF, so boom, I write my GCF. It is part of my answer. That's my first factor. It's not just a monomial, though, it's a binomial. But it's still my GCF. And as soon as I write down that GCF, boom, another parenthesis. Because I'm going to turn a sum into a product. So if I divide out x minus 4 from both of these, what's left behind in the first term? A 2. And then plus 3y. And this is, I want you to see how it goes from a sum to a product. You write your GCF and boom, opening parenthesis. Because that pulled out a factor, so the rest is going to be the other factor, which starts with a 2 and then positive or plus 3y. That all canceled out, close your parenthesis. And so in this case, instead of a monomial times a polynomial, we got a binomial times a binomial. And that takes us into our next type of factoring.
So that's the answer.
That's the answer, yeah. Because, and look, are these linear? Are there any exponents?
No.
So if they're linear, you know you're done. As long as you took out a GCF first. If you forget to take the GCF out of the beginning, you might still be able to keep going if it's linear. That's why it's always job 1. One of the reasons it's always job 1, take out a GCF first. Because once you take that out at the beginning, you know once you get down to linear, you're done. You don't want to be like, oh, but wait, is there a number in common? That gets really messy. And sometimes it just makes the whole thing wrong. But at the best, it just makes it messy. Huh? So if you take it out, there's no initial GCF. There was. That's because that's all we were doing is GCF. So we took out the GCF. This is left. As long as they're both linear, you're done. There's nothing else you can do if there's no exponents.
Is there another way to work this out?
Not really. That's the same idea as the GCF. It looks a little messier than, like, say, this one or the first one we did, but it's the same idea. How many terms do you have? I've got 2 terms. What do they have in common? Divide that away, and that's your first factor. And what's left behind is your second factor in parentheses. And this right here is part of what we're about to do now. So we move into the next skill.